If I can just quickly move on to our next speaker, our final speaker for today, if I may, and that is Thomas Haida. So welcome, Thomas. Thank you so much for joining us. Thomas is a principal in data and AI at a very small boutique company called Microsoft. Right?
Thank you.
I actually joked. I made that as
Yeah.
a joke earlier, and I
No,
didn't think
this is okay.
I think it's quite fitting. So Thomas has over 20 years of experience in technology and transformation, and your specialism is in technology, specifically artificial intelligence, machine learning, advanced analytics, and big data. And you are also experienced in working in venture capital, building global virtual teams, and driving global business strategies. Thomas, I am very excited to hear what you've got to say. I think you've got a lot of passion and are very much a technologist at heart. And I think it's a lot of what's going to be coming from your heart that we'll be getting from your presentation. So off you go.
Thank you very much, Roxy. And thank you for your points, Eric. Democratization has become key. And for a lot of stuff you're doing today, you do not anymore need developers in the amount you needed it times before. So a warm and welcome and virtual welcome from my side. I'm Thomas Haida, a principal at Microsoft. Background 55, married, one daughter. Now my hair has become sterling silver. I'm getting old, yeah, and I learned a lot. And at Microsoft, AI and data and all, let's say, the stuff I'm doing has become key. And one thing first, as long as you're not doing gaming, there is no competition for Microsoft. Microsoft will not stop Xbox. Yeah, so I have also an Xbox, but we do not monetize any vertical businesses and like finance, healthcare, manufacturing, and so on. My interest has really become artificial intelligence, and what I want to do with you today is to take you on a journey into the world of artificial intelligence. And to start the journey, we need to differentiate what is analytics, what is machine learning, what is prediction from artificial intelligence. Then I will give you an overview of our AI tools. Okay, how are you doing this? And I won't do a demo, but I will do a short explanation what we have done with artificial intelligence. Yeah. I had the pleasure in 1993 to meet Joseph Weizenbaum. His program, ELIZA, was the first program to master the Turing test. So the Turing test is passed if a human on the other side, and it was 93, it was just keyboards and a screen. And if the human on the other side cannot see, is it a man or a computer on the other side? And ELIZA passed the test by using a psychology imitation game approach. And the doctor is called Rogerian psychotherapist. I will provide all the links from this from my presentation in afterwards, so you can look it up. It was great. He actually hated it, and the thing is, why did he hate his own program? Because it's artificial intelligence. It's just a batch program. Yeah, and he was looking for doing artificial intelligence. And to start, what is artificial intelligence? I have brought you on a classic game. Hopefully many of you know it. It's called Breakout. You know, you have the pedal down here and you can just move left and right, and you have a ball bouncing back and forth, and you have to prevent the ball passing your pedal and shooting it up, and it destroys then all these rectangles up here, yeah. And games, oh sorry, I didn't want to do this. Games are very good to master, to be mastered by artificial intelligence, because at the beginning you tell the AI nothing about the game. It just tries. After 10 minutes, you see the pedal going left and right, and it sorry, I do not must change this, and while going left and right, it misses the ball very often. But after 120 minutes, the same AI never misses a ball again. And I think this is pretty normal, okay, because it can understand, okay, it sees the ball coming down and it just has to place the pedal to the right place. And but what happens on 220 to 240 minutes is this is astonishing. Don't know if you know this trick, grabbing a tunnel on the left or right side. If you do this, the ball passes by and goes up and down and destroys a lot of rectangles without you doing anything down there. And the AI just needed 240 minutes. I remember somebody told me the trick, and this is really, I think we are now 1990 or 86 when this games came out, and it was a cool trick, but there you see the power of AI. Why are AI companies using games for checking how good an AI is? It's very, very good because a game has clear rules. You can make these rules, you can write it down, and it's easy to measure by the score. Yeah, you see it on the top side. The higher the score, the better the AI performs, and the use of these two measures then brings a very impressive result for breakout on the one hand. And now let's move to two other games. Yeah? Maybe all of you know the game chess. This is on the left side. And on the right side, you see Go. It's a Chinese game. Yeah? It's basically, it's black and white stones. And if you encircle black stones with your white stones, every black stones within the white stones will turn from black to white, yeah, and vice versa. The difference is, see if you look into the details of the games. You have with chess, you have a 21st move options. With Go, you already have 361. The second moves with chess is around 400. With Go, it's already 130,000. And approximately legal board positions with chess are 4 times 10 exponent 44. And with Go, 2 times 10 exponent 170. So these numbers are hardly to imagine. Yeah, what is 10 or 4 times 10 exponent to 44? To make it a little bit visible, the world or the Earth approximately has 10 exponent 50 atoms. The atoms in the universe are 10 times 10 exponent 86. And now to come to 10 exponent 172. You have to create a universe for every atom you have in the universe, and then count these atoms again, and you're close by 110 10 times 172. And there you see the difficulty, because of the sheer size of the problem. Mathematicians and informatic people were sure no computer will beat a world championship before, I think they said 2030, something around. The compute power won't be enough, yeah, because of the sheer size of the program. The IBM Deep Thought was beat by Gary Kasparov at 10th Feb of 96. AlphaGo beat Lee Sedol. He's the world championship in Go on 15th of March in 2016. And it was crazy, because some moves in the and it was really declassifying for Lee Sedol. Yeah, it was, I think, 7 parties of game, and he only won one of the games. 6 he lost. And here we see what is behind AI. On the right side, you see, with deep thought from IBM, you see pure computational power, which reflects analytics, machine learning, prediction out of machine learning. You have mathematical regression. You can calculate it. On the right side, you have two technologies. You have neural networks and reinforcement learning. On the left side, you have a computer. You can stop the computer at any time, and you can look where in the code the computer is. On the right side, you have a neural network, and you do not see anything. One at the first party of the game between Lee Sedol and AlphaGo, the computer did nothing for 2.5 minutes. The programmers were sitting there, and they could not do anything, because you cannot look into a neural network. You see it's working, you see there's action going on, but you cannot understand it. And one crazy thing happened. I think it was in the 5th or 6th episode or round of games. It was in the beginning, and AlphaGo made a move, and all the people, all the high class champions of Go said, now it will lose, because it did a wrong move. It did win. And the reason is, no man has seen this move before. Because what you're doing is, and what the guys from deep learning did at those times, they created a general AI who knows how to play Go. Then they duplicated it and let play it against itself. And so AlphaGo grew stronger and stronger. And this is, I think this is the big power. And please, I also want to if you bring in questions, what is it behind it, and why do you think AI is so important? Please bring in questions as well. So I have noted down now the facts. We are talking about analytics versus deep reinforcement learning. On the one hand, you have, and this is chess, or let's say anything you can compute. And most of the stuff we talked today about, yeah, we talked about big data and analytics of big data, and a mathematical way of taking the data taking part of the data, making a model, and check the model with test data the model has not seen before. And if the model succeeds with 85%, okay, that's enough, we can take it. It's a universal use of historic data. So you use a lot of data, you analyze and rank data for the desired outcome, and you brute force analyze it. That's exactly what Deep Blue did. And the challenge for doing analytics, and now we are coming to the point. We heard a lot about also how to bring in factors from the outside, like what do customers want? You can bring in data from anywhere, but you have to classify it to make use of the data if you do analytics. And if the sheer size of the data is too big, it limits your model because you cannot anymore compute it. On the other side, you have deep reinforcement learning. You have defined rules and boundaries, which are clear to everybody. This AI, and I must be very clear here, is highly specialized for one job. And AlphaGo was highly specified to play Go. Yeah, and this was the beginning. So you cannot use this model for playing chess. At least this was the beginning, but you can do it as well. Today, I think no man has a chance to win against these machines with chess or with Go. They are too strong. AI learns by getting rewards and penalties. If you remember breakout, it's a reward if one of the bricks is removed from your board, and it gets a penalty if the ball passes by and the game has to create a new ball. Yeah, and then you go on. And maybe it's limited by 3 balls, and you're done if you have lost 3 balls. And we have learned from AlphaGo, and this was the beginning. AlphaGo beat Lisa Dole. Afterwards, Google created AlphaGo Zero, which is basically they teach the system nothing, like breakout. AlphaGo, the first AlphaGo had games from learned by redoing games which men and great Go masters have played before. But also remember, man is making mistakes. Yeah, so AlphaGo also learned the mistakes. AlphaGo Zero, if you bring in only the rules and say, okay, just start playing the game by the rules, you know, like in the breakout thing, it will go very wrong at the beginning. But with simulation and playing together, it's a very strong method to learn. What will happen now? And AI, and also not to forget, it plays against itself. So you can duplicate this neural net. And now, for instance, cars, self-driving cars, they learn by driving in simulations. You cannot do the same breakout approach with a car, because then the car would crash into anything and it would destroy something. But you can do a simulation. You can let the car run in a simulated world and learn driving by itself in that simulated world. And then transport this into the real world. And it's only limited by rules and boundaries. And this is I think the challenge, the problem you want to solve needs to be able, you need to be able to formulate the problem you have, and to formulate the boundaries and the limits and the rules of the game. If you can do this, it works. Where are we going? At the beginning, and all of you know this, computers were very complicated. I don't know if you remember the times where you only had a terminal, and it was really horror to do any programming. Today, technology learns us. What AI also can do very good is imitation. It learns from what we are doing. It's observing, it can listen, and with all these points, technology learns us and discovers how it can help us. Because, and I think it was said before, I do not see AI as a danger. And I now do not use fintech, I use healthcare. If you use AI in cancer, in finding a cancer in an MRT, it can be very difficult because these MRTs are very, very large scans of your body, and it's easy for a doctor to miss something out. And what the AI can do there is just have a screening of the MRT and saying, hey, if you do not look anywhere, just look into this point, and that point. And the rest is your decision. So AI is like a helper on your shoulder. And now we are coming to the tools. Yeah. So what we are doing, and this is now on this screen, yeah, it's anything on there from forecasting and anomaly detection. Also points in here are analytics. Yeah. So this is mixed up. It's not everything is AI here. Yeah. But if you look, for instance, into computer vision, this is AI, because you have to bring down an image, and you have to make the computer understand what he's seeing, what it is seeing. Sorry, it's not he, it's it. What it is seeing, and you have to bring it in with a neural net, because otherwise it cannot understand the world. And these are the challenges. Or what you also see is speech to text. You talk something into the computer, into the API, and what you get back is either you have pre-qualified the language before, or if you have not done it, the computer can also try to get your language. Maybe you all use these translators, and they have become tremendously good. I only can tell you to give it a try. It's a different world than 5 years before. Yeah, the translation power is very, very good. And speech to text, it works also very good. I personally dictate very often emails, SMSs. I do not type anymore because it takes too long. And the same goes the other way around, text to speech. I send a text to an API and said, I want to being spoken back to me by a woman with voice. And then I get an MP3 back and can use it in my program. It's a different way of using programs. And one example, and I cannot do the demo because we are time constraints here, is cognitive search. Maybe everybody knows the picture here. Yeah? It was taken on November 22nd, 63, and it's the assassination of John F. Kennedy. And yeah, the government now released 34,000 documents related to the assassination. They are printed on paper, so you basically have no information. And this is where AI comes in. And it's not only printed, it's also hand notes on it. It's photos like like this year from Lee Harvey Oswald, and on the photo you see New Orleans, LA. So computers can read this, and they can give this information. They can understand it and bring it into combination. We have created a JFK demo. I will also add all the links so that you can try it yourself. At those times, we found out, we just brought in the 34,000 documents. Basically, it's all the data comes into Azure storage. Then the content is extracted. Cognitive skills are OCR, handwriting, computer vision, entities, and knowledge, because CIA, FBI, they have a kind of hidden language where acronyms are used. You also give the computer this to create a big graph of information. And then you can look into this information and you can find out. And we just typed into the search engine SQL, which is our SQL server. And we found out that the CIA used an SQL server plus Lotus Notes to store all the files and make it available to other government organizations. This was, and this is, you can find out information which is hidden to you. And that's also what I want to give you. The demo, we don't do it. And now I'm coming to the conclusion. What is coming and what should we be aware now? I think this technology can be used against financial fraud, can be used to support cyber security. We also do this internally. We have a cyber security division which does nothing than trying to find out all these frauds and crooks out there who are making bad things in the internet. Yeah. And you can automate personalized customer products, but not on data you already have. Maybe you can find, or the AI can find patterns you have not seen yet before. And another point is quantum compute, but this will then be another complete, let's say, post or lecture. And what's very important with AI is they should treat all people fairly. We have really put a lot of effort into using the use of AI should be safe for everybody. It should perform everything safe and reliable. It should respect privacy, and it should empower you. It should not destroy you, it should empower you. And one thing, at least we should understand the AI or what it is doing, even if we cannot see the program anymore. This is the big problem of with neural networks. You cannot look into it. It's a black box. And to finalize, yeah, this is not last week now. It's wrong. I need to fix it, yeah, because I made this presentation on 21 first. President Biden is still delaying the release of the final documents. So I hope it was interesting for you, and it was a different view on what's the difference between AI and machine learning and the analytical stuff we do most when we talk about prediction. Any questions?
Wonderful. Well, Thomas, I think we have several questions pending here.
Yes.
What I think we will do, I think we shall invite these questions for our panel. Thank you so much. That was very, very insightful and also quite thought-provoking. I think the last, obviously, two sessions have really delved quite, deep into sort of really thinking about AI as more of an art form in a way, and then obviously taking a more academic approach to it as well. It's been quite enlightening. So, right.